You know what? Welcome back to Bad School University. I hope you guys are excited for a conversation about science fundamentals. And today's topic is unit conversion. Unit conversion is a useful form of dimensional analysis that allows you to swap between units of measurement. It uses conversion factors, which are also just funny looking ones. For example, you have 1 meter per 100 centimeters, and when you divide the two, that equals 1. So you can just flip that over to 100 centimeters divided by 1 meter, and they're equivalent statements. So that's what's going to be useful in this exercise. Alright, so for this first example, we're going to go from inches to centimeters. So we know that 1 inch is equivalent to 2.54 centimeters. So you can use that fact to make a conversion factor where you have 1 inch per 2.54 centimeters. And we're going to use 30 inches for the example. So you want to flip the conversion factor over. So you just multiply 30 inches by 2.54 centimeters divided by 1 inch. And then the units divide out, leaving you with centimeters. So you just have 30 times 2.54 centimeters. And that's going to equal 76.2 centimeters. So to do the sig figs on here, we just have one significant figure. So the answer is going to be approximately 80 centimeters. For the next example, we're going to go from miles per hour to meters per second. So you have 5 miles per hour here, and your conversion factor is going to be 1609 meters per mile. So that gives you meters per hour after you divide out the miles. And then you know that 1 hour is 60 minutes, and 1 minute is 60 seconds. So you end up with 5 times 1609 divided by 60 squared, and that's going to be in meters per second. So when you do the math here, you're left with 2.23 meters per second, which is approximately 2 meters per second, because we only have one sig fig. With this next example, we're going to go from fluid ounces to gallons to milliliters to liters. So a bit out of the way, but just as an exercise so you can see what it's like. So we're going to start with 12 fluid ounces, size of a proper beer can. And that's going to be, 1 gallon is 128 fluid ounces. And then there's 3,785.4 milliliters in 1 gallon. So the ounces are divided out, and so are the gallons. And then 1 liter is just 1,000 milliliters. So multiply that by 1 liter, and then 10 to the 3 milliliters in the denominator, which is going to give 12 times 785.4 divided by 128 times 10 to the 3rd. That's going to be in liters, and so that's going to give 0.35 liters. So you get the answer in a very convoluted way, because I just wanted to show you how to convert between all the different volumes. In this last example, we're going to convert between areas, so from inches squared to millimeters squared to kilometers squared. That way you can see what to do when the units have an exponent. So starting with 10 inches squared, you just take the normal conversion factor for inches to millimeters. So that's going to be 25.4 millimeters in 1 inch. Because you want squared units, you square the whole conversion factor. And then multiply that by 1 meter per 1,000 millimeters. And square the whole thing. And you can call that 10 to the third if you want, it doesn't matter. And then you multiply that by 1 kilometer per 1,000 meters. Square that conversion factor. So you're just left with 10 times 25.4 squared divided by 10 cubed to the 4th power. And that's gonna, oops, not meters. That's gonna be kilometers squared. So you get 6,451.6 divided by 10 to the 12. Because remember, when you have, let's say 10 to the 3 to the 4th power, you multiply the exponents together. And again, that's in kilometers squared. And then you get about, well, let's say approximately 6 times 10 to the 3, because the numerator is about 6,000, divided by 10 to the 12 kilometers squared. And that gives you approximately 6 times 10 to the minus 9 kilometers squared. So that's it for today. I'm gonna go. Class dismissed.